Good afternoon, everyone, or good morning, or good evening from wherever you're joining around the world. We're very pleased to invite you to our next talks, this time focusing on Germany as part of our series, focusing on different countries around the world, assets. As you may remember, we had a session just a few weeks ago, focusing on the United States. And we're very pleased to this afternoon to be working in collaboration and partnership with one of our members, the German Combined Heat and Power Association, B.KWK, as its acronym. And as you know, at least if you're based in Europe or even around the world, Germany represents a fairly significant CHP installed base. And we're very fortunate today to have three experts joining us, representing both the association, but as well as different commercial interests to their experiences. So we're very happy to have them all join us today. And just some few housekeeping points. There is a Q&A function. There will be a Q&A session at the end of the three speakers. You are more than welcome to pose your questions during the webinar, and we'll get to those questions at the end. So don't forget the Q&A function, and we'll try to get to all questions. Also a reminder, this webinar is being recorded, so if you missed part of it or you would like a colleague to take a look, this webinar will be made available on the CWC website, as well as the presentations that will be presented by our eminent speakers. So without further ado, I would like to welcome Stefan Liesner, who is the Vice President of the German CHP Association from B.KWK, and he will give us a deep dive introduction to the cogeneration market in Germany. So I'm very pleased to have you with us, Stefan, and we're looking into your experience and insights and what's happening in Germany, and then also exciting things are happening from what we hear, and looking forward to the future development of CHP in Germany. So the floor is yours, Stefan.
Yeah, great. Thanks a lot, Hans. I hope everybody can hear me.
Loud and clear.
Yeah, it's fine. So let me share my screen. So I hope it works now. First of all, once again, Hans, and to the COGEN World Coalition, a big thank you that we, or Germany, is getting the floor here and leading this country focus webinar today. As you've already said, Germany is a quite, let's say, experienced market with regards to CHP, but of course also at the moment with a lot of challenges. Not only for CHP, but for the whole, let's say the whole society. So energy politics in Germany, like in other countries, is one of the core topics we have right now. And so I think Germany, with getting rid of nuclear and coal at the same time, is very, very special. And at the same time, we are currently we're having a parliament which is being led by the socials and the liberals, and in particular the green ones. And so there's a lot of interesting discussions we're having association-wise, and I'm happy to share these slides. And after my presentation, we'll be having two let's say core key players of the German market, which is Sokratherm, represented by Joachim Voigt, and also Max Funke, representing Kraftwerke. So they're also a member of the board of B.KWK, and I'm happy to hear also there, or you can be happy to have their practical experience from certain projects. Just one thing in advance, when I created this presentation, I wanted to avoid just to skip through all the legislations and paragraphs of the CHP Act in Germany. So at the end of the presentation, I've made a little annex. So if anybody is interested in having, let's say, the German legislation, or at least a summary in English words, so the presentation will be set online on the CWC webpage. So whoever is interested or wanted to doing a deep dive into the legislation, then please feel free. But I think for this 20-25 minutes, it's just too much. Yeah, just to introduce myself, like Hans already said, Stefan Liesner. Yeah, my main profession is yeah, the head of marketing and public affairs at 2G. So we're a manufacturer of CHP plants and also heat pumps nowadays since last year. Yeah, with a fleet on the ground of approximately 10,000 engines around. But today, more in the function of my, let's say, main voluntary position, which is the vice president of the German association B.KWK, Bundesverband Kraft-Wärme-Kopplung. But I'm also holding several other voluntary functions, and this also, I think, gives a quite good, let's say, overview where CHP stands at the moment. So, of course, the most important association is the B.KWK, but for us, let's say, acting when it comes to political action, it's more important, or currently of most utmost importance, to have a deep, let's say, cooperation with the wind guys, with the heat pump guys, with the PV guys. So political wise, I'm also quite active, yeah, in the German Federal Association for Renewable Energy, the BEE, and also the local one here in North Rhine-Westphalia, where 2G is located, the so-called LEE. So, and this really brings us in the position, or let's say gives us a political voice in terms of this integrated energy system. So you will see later on during my slides that nowadays it's not the case anymore. A CHP on a Sunday afternoon, a sunny Sunday afternoon, and people are getting money for burning natural gas. Of course, those are not the things we want to give to the politicians or we want to advocate for. So for us, it's let's say about yeah, system argumentation, political argumentation, where CHP is a kind of backbone of the whole energy system. And this is also why it's very, very important also to have these positions in the other associations. So who is the B.KWK? What are we doing? So B.KWK is yeah, the German Combined Heat and Power Association, representing manufacturers, universities, utilities, planners. So in total, almost 400 members we have. The association is located in Berlin, and yeah, as you can see here, this huge variety. So it's not only manufacturer based. Yeah, we perceive ourselves as a kind of, let's say, experts of the energy market. So for us, it's not only about the technology; it's really about helping to set up, yeah, just an energy system that works at the very end. So, coming to the energy market itself, which challenges do we face currently in energy policy? I think that every country, everywhere in the world, energy is a big topic. And I think what's also everywhere the same, this in Germany, it's a quite core thing where all political discussions flow around. It's the so-called energy triangle. So whatever happens, whatever kind of technology you have, or whatever, you need to meet the best combination of security of supply, of course, a kind of economic viability, and of course, at the very end, sustainability. So, and as you know, there are several positions. So when you have the typical Brussels NGOs, of course, everything is about sustainability. When you have our typical customer, like in hospital, of course, for them, security of supply is of utmost importance. Or other example, when you have this classic industrial application, 150 people, mid-sized company, whatever. Of course, they're interested in having green solutions, but at the very end, they need to position themselves in the market. So all these discussions flow around this energy triangle in Germany. And what's also quite interesting, I mean, many people are complaining. I was mentioning currently the Green Party, the Social Party, the Liberal Party. There's a lot of rumor in Germany, a lot of complaints. But no matter what kind of party you advocate for, what they've managed to do is to reach a kind of general consensus. So we'll be facing an increasing energy demand. We have wind and solar instead of coal and nuclear. So there's this nuclear phase out that took place last year. And also there's a big consensus that electrification is possible or is necessary wherever it's possible. So especially in the heat sector. So nobody remember 5 years ago or 10 years ago, even we at 2G or B.KWK said, oh, heat pump, it's rubbish, we don't need that. And it has entirely changed. Of course, the heat pump is a perfect technology, but, and you will see that later on, it depends on how you integrate it in your energy system. And of course, mobility, EV vehicles, also a big topic. So all the discussions we have are around the challenges apart from this consensus. So the expansion of renewables is not as quick as it's actually necessary. The grid expansion is slower as needed. So we have, so stepping back into the company perspective, there are lots of customers, they want to buy a heat pump of 2G. And after half a year, they come back, okay, we don't get the permission to install the heat pump. So can we have a CHP instead? Just as one example. Of course, wind and solar, highly volatile. Long-term storage, hydrogen, of course, a big buzzword, but so far there's no, it's not, let's say, really in place. The demands we need actually. We have rising energy costs, implementation of the heat transition, and also the financing of all the energy measures. So at the very end, who pays for all these heat pump things, and also lots of legislations, the so-called GEG in Germany. So this legislation that regulates where the heat comes from in houses. So lots of political discussions here. I was mentioning the big consensus. Stepping to the next to the next slide, that we will need a massive expansion of wind and solar. And I don't know the numbers of all Euro countries in the world, but when it comes to wind and solar, most of the countries, they have curves or perspectives that look like this. Of course, there are also other ones that say we need at the end 700 gigawatt installed capacity or 500, whatever. It doesn't matter, but it's at the very end, it's important. And I was mentioning that consensus that we need to expand that. And now maybe coming to the first challenge. So when it comes to the generation, renewable generation, wind, solar, everything is entirely clear. And when it comes to the heat side, of course, the heat pump, one of the core solutions. Okay, nice plan. But when you can compare currently, that's the monthly gas consumption in Germany of the years 2022, 2021. It's a kind of U-shaped curve. It's a matter of course in Germany with strong winter times. So the heating period somewhere between October and March, April. So there's a lot of gas consumption there. And when you set this,
let's say, this was a slight problem with my mic. Hope it works again. And if you set this in relation to the actual nature, that means when the sun is shining, you see this typical solar peak. So Germany, I was mentioning the heating period between October and March, April. And when you see percentage-wise, it's just an example from Upper Bavaria. So only 2% of the yearly sun shines in December in Germany, in Bavaria. And you want to solve that problem, so get rid of natural gas and having a solution heat pump, but you don't have enough renewable energy. So that's currently the main discussion we're having. So that just to see this wish, the target you have, renewable energy operates a heat pump, thermal energy with 0 emissions. And in reality, it often looks like this. You have coal power plants operating these heat pumps. And at the very end, the heat pump is even the worst solution when it comes to real CO2 emissions. Of course, politicians have recognized that, and there are plans, and the ones who are German know this word, and the ones from other countries might have heard about that, the German Kraftwerk-Strategie. That means power plant strategy. So you can see here the expected development of power plant capacity in Germany. So until 2030, 38, they hope to have it realized 2030, getting rid of coal. So brown coal and hard coal. So I was mentioning nuclear, the yellow one here in 2018. This entirely we phased that out. So we need gas power plants, or let's say power plants based on molecules. Of course, in the long run, they need to be green. And we are doing everything, let's say, to ramp up the hydrogen industry, to have more, let's say, biogas. So, but from a technology perspective, first of all, we need gas power plants. And the core question is currently, and this is what we're doing, this is, let's say, our main policy effort at the moment, is to convince people, to convince politicians that at the end, there is no better solution than a decentral one. Why is that? I mean, you know that, I guess most of you are friends of combined heat and power. You have very high, let's say, exploitation of the gas itself. We have an H2 readiness already today. So yeah, all our biggest manufacturers in the association, we have realized more than 40 projects based on 100% H2. All the manufacturers, they have efforts, or they're doing efforts so that every, let's say, CHP that is being installed today can be retrofitted to hydrogen at a later stage. And what's maybe even most impressive is the capacity, the potential of CHP. So you've seen the numbers of the power plant strategy, somehow 80 gigawatt in the next 30, 40 years. And the first target is having 10 gigawatt until 2030. So the German CHP Association, or members of the German CHP Association, could install 6 gigawatt per year. So if somebody, coming back to 2G, orders today 100 hydrogen CHPs or even 1,000 CHPs, they could be delivered within the next 12 months. So there's also from a time range perspective a very, very huge potential. And additionally, reduce grid expansion. I was mentioning the example here in our company of customers, and at the very end, it's a matter of course. If let's say a mid-sized company wants to install a heat pump and wants to equip his premises with, I don't know, 10, 20 charging stations for e-vehicles, then it doesn't bring any benefit if 20 miles away there's a big gas power plant. So we are currently really advocating for this decentral approach. And as I was mentioning at the very beginning, it's very important to have the wind guys and the solar guys on board because they have entirely the same opinion. So what does it mean for our members, for the companies, especially the manufacturers? So first of all, when you see the left-hand side, one of the three main core homeworks, let's call it like this, we need to be fit, we need to be ready for renewable gases. So natural gas is not a big future thing. So all the members are focusing very, very strongly on hydrogen and biogas, of course. To admit, there are also lots of members that originally come from the German biogas market, so there's not a big deal with that. Then we have, in general, larger CHP with larger heat storages and a lower operating time. So at the beginning, I don't know, a couple of years ago, 6,000 operating hours a year, whereas nowadays it's maybe 2,000-3,000 depending on the project itself. And then on the right-hand side, and this is maybe even as much important as the mechanical R&D work, it's the software. So this inclusion in the energy market and artificial intelligence, all these kind of things is also, I can speak, of course, in detail for our company, but also for all of the other companies. That's one of the core things to focus on these software and digital solutions. Yeah, sector coupling, integrated operation. So I was mentioning the political things and also the technological things. What happens nowadays? I'd like to give this one example. It's quite funny. It's from a presentation I've made for a school class here at our company, just to explain them what is it all about. It's very, very difficult. But at the very end, coming back from technology and coming back from any legislation or whatever, it's a matter of course. There's lots of time, there's wind and solar, and that's the typical, let's say, anti-argumentation. When you speak to a fossil old guy, they say, okay, you're talking all the times we need renewables and it's getting cheaper. And what happens at the end? We have more renewables and everything is getting more expensive. This is the typical argumentation of those guys. So I think both of them are quite not right, but where does it come from? So 80%, could be 70, 90, whatever, wind and sun, of course, is very cheap. And if you make yourself clear, 80% of the time, it's very, very cheap to produce energy. But when wind is not there and sun is not there, you need any kind of storage. So batteries, hydrogen, biogas, whatever. And of course, these 20% is very, very expensive. It's just an example here, 50 cents. It could maybe, I don't know, 90 cents, €1. And also this 10 cents is only an example. I was mentioning for a school class only to make them clear how do the high prices come from. So the central question we're having, and this is not only the CHP guys, it's the entire energy world, is developing a market model that represents exactly this. So at the moment, I was mentioning these feed-in tariffs, there is this Renewable Energies Act or CHP Act, and there are certain amounts of cents you're getting for as a feed-in tariff. So in the future, we need to develop a model that a hospital, an industry, or whatever who invests in the CHP is getting any kind of benefit for having this secure power in the grid. And this is also what currently is being discussed in Berlin quite heavily, together with Brussels, of course. As I was mentioning, so it's about a combination integrated energy. And at the very beginning, I was saying, okay, heat pump, coal power plants. Of course, the heat pump is one of the core technologies. I'm not against the heat pump. I mean, we as a company are even have started to manufacture them. But especially in times when there's enough renewable energy, then the heat pump is the most efficient heat generator. So at the end, it's about this combination between CHP, which is, I was mentioning, the most efficient type of power plant. I'm pretty sure, I know, Joachim, that your case is, I think, also an example on that. At the end is, how do we manage to do that? And what are, let's say, the way of operating these kind of combined system? Because the combination of PV, which is more or less a matter of course for most of the houses, so the combination of PV, heat pump, CHP elegantly combines the advantages of each system. And at the very end, the integrated operation reduces emissions and energy costs. You can see that here in the next slide. So that's the German market in 2023 between January and end of October. So you can see here the blue ones are the times where energy prices are quite low, and the red ones are the times where the energy prices are quite high. And of course, that are exactly the times where there's a lot of coal power in the system. And this combined, let's say, combination of heat pump and CHP is exactly represented here in this sheet. So if you have a smart combination, you can reduce CO2 emissions for the whole country at the end, and at the same time reducing your own energy costs. So at the end, it's about a smart project management. Also, this is a more technical slide, let's say. This combination brings a lot of benefits because also from a thermodynamical perspective, you can combine it. So of course, the CHP, you have a lot of waste heat you cannot use. But what you can do is using the waste heat in order to increase the efficiency of a heat pump, of an air-water heat pump, for example. So there are also lots of thermodynamical opportunities that makes this combination highly viable. And then, let's say, coming back from CO2 emissions and energy costs and the thermodynamical thing, there's also from let's say, from a year or month perspective, lots of benefits. I don't want to step too much into the details of this sheet, but what should be the message of this one? So I was mentioning at the beginning, or one of my first slides, so what is the heat consumption in Germany, or what's the gas consumption in Germany with a very hot summer and a very cold winter? So in summer times, as you can see here, the CHP in the middle has only a kind of backup function electricity-wise. In summer times, and with an increasing amount of wind and solar, the time where the CHP will deliver heat in summer will be reduced and reduced. So maybe a backup function for electricity, but less and less operating hours with heat in summer. On the other hand, the heat pump is, let's say, happy. The environment, average, I don't know, 20 degrees in summer. and also the heat utilization. You have a backflow temperature, just an example here, the blue line at the very top, 55 degrees Celsius. So you see this whole scheme, the heat pump has the lead here. When you compare that to spring and fall, for example, it turns to a certain extent. So there are times in spring and fall it's getting colder, average only 10 degrees. The backflow temperature only 40 degrees. So there are more and more times where you need the heat. And then in these times, the CHP can even serve as a kind of booster. So when you see classic air source heat pump, only 60 degrees flow temperature, and then having a kind of booster with the CHP with a flow temperature of 85 degrees. So, and as I was already saying earlier, at the end, it's a matter of technical and smart combination. And this is what's being done by companies like Sokratherm 2G or Kraftwerke or whoever, member of B.KWK. And then the extreme example in winter times when you have only 0 degrees outside ambient temperature, then of course the CHP has its strength as a kind of booster, having longer operating hours in the winter times. And if you compare that, also the total power of the heat pump, you see that here the total power of the heat pump is only 120 degrees, 120 kW thermal here. Only an example, but just to show what's the thermal or the power development of these heat pumps in winter times. So I know that the other two guys will also have some examples. So just a few sheets to first ideas how this could look like. So you have here just a small industry combination, 50 kW CHP plant with geothermal solutions, with PV solutions, with biomethane use here. You have another one, I was mentioning these waste energy or waste heat of the CHP. That's an example by a German Stadtwerk in Bad Lauterberg. They're doing exactly that. So they use the waste heat and having a heat pump in the backflow, and by feeding the heat pump with the waste heat, the backflow can be increased from 60 to 60 degrees Celsius for the CHPs, so that at the very end, the peak load boiler is not used, or at least used less with this combination. Also another example of Lemgo. So Georg Kleene, some of you may know him. He is one of the managing directors of Stadtwerke Lemgo, German utility. And they're also doing this perfect combination of CHP heat pump in a large scale. So with the district heating system, you can see here the combination, the heat storage volume, the orange field at the bottom. You have the district heat load, the yellow line, and the heat electricity generation, and everything in accordance with the stock market price, these green pluses in the middle. So also again here, utility perspective, it's about the smart combination. So what's the conclusion? First of all, I think matter of course, whenever there's sufficient amount of renewable energy in the system, heat pumps are the first choice, of course. On the other side, there's no more efficient system as a backup than a CHP. So it's about a combination. CHP systems, 100% H2 proven. I was saying lots of projects already being realized and more are coming. Then the 6 gigawatt flexible power plant capacity. That's also very, very interesting and important to see the potential. We had to face declining market in the past years, unfortunately. And so it's a very, very crucial time at the moment. And that's why we all together doing lots of policy work at the moment, because the growth potential, I was showing the numbers, so how many gigawatts there are needed. So there's a massive growth potential. So that's interesting times at the moment. And was also quite interesting. I was mentioning that with some of the examples. So at the very end, we have to see that whoever, be it a hospital or utility or an industry that invests in a CHP, does at the very end bringing even macroeconomic benefit because the number of these big, large power plants on the green field, they're being reduced. So as you see, a lot of work for us. And yeah, I'm also more than happy to share the experience of the other associations and to see the views from the CHP world in other parts of the world, and looking forward to the discussions at the end. Thank you.
Thank you, Stefan, and right on time. So we appreciate that, and excellent insight. Obviously, a lot of challenges in Germany, and some challenges faced in many countries around Europe, but also globally. But also, as you mentioned, a lot of opportunities. And of course, there's a lot of potential, at least the technical and economic potential for CHP. We just need to get the right policies in place. And that goes for Germany and every country around the world. So thank you for that, and thank you for your insight. And just as a reminder to everyone, the presentations will be made available on the CWC website, and also we will circulate an email after the webinar, so everyone is informed. Following the introduction and overview of the situation in Germany, I'm pleased to go to two examples of best practices in Germany. So our first speaker is Joachim Voigt, who is the sales director from Sokratherm. And he will present the first best practice. And just a reminder to everyone, please do use the Q&A function. It's there, so we'll collect the questions at the end and go through them. But for the moment, the floor is yours, Joachim.
Thank you very much, Hans, also for the invitation, and thanks to Ben also, and thanks to Stefan for the interesting introduction and the first view on the German market. I will pick up the line and show you an example of how cogeneration can be implemented successfully currently under the existing German policy schemes. First of all, we've got one picture of what Stefan also said in the beginning, that 10 years ago, cogeneration and heat pumps always were thought separately, either heating with a heat pump or heating with a CHP. But in the past years, we experienced that it works very well thought together, cogeneration and heat pumps as a system. This first slide is quite similar to what Stefan also said in the beginning, so I can go through it quite quick. You have seen that both curves from gas consumption and, on the other hand, the renewables share in the grid. This is in the bars below that below that gray gas consumption line. The whole renewable energy share is listed in the German electricity grid. So what you see is that in winter times we've got a share of a bit less than 40%. And in the good months, like May and August, the share raises to close to 60%. And one of the main policy targets is to expand photovoltaic production. So this is what is represented in yellow below. And if there is a big factor in photovoltaics, you will gain close to nothing in the wintertime. So providing sufficient green electricity to be utilized in the heating market will remain to be a major challenge also in the future. So what are the conclusions? The first conclusion is that heating with heat pumps should preferably be done in the transition season, in which a relatively high share of PV electricity and high share of renewable electricity is to be provided from the grid. And during this time, also heat pumps with air as a heat source have a high level of efficiency. So the COP, the coefficient of performance of a heat pump, is 4 and higher in this time of the year. And on the other hand side, CHP units should preferably be used in the wintertime at low ambient temperatures. At that time of the year, the COP of the heat pump drops, in addition with a high heating water temperature, which is required in the heating network. So yeah, on the one hand side, heat pumps with a poor efficiency are you use CHP instead of heat pump with poor efficiency in the wintertime, and simultaneously the CHP then covers electric residual load, which is especially needed in the wintertime, as it was explained before. And from these considerations, we developed a scalable system solution with CHP unit, heat pump, and a master control system for intelligent operation of the whole plant. So the CHP will be designed a bit bigger than in recent years, with about 40% of the building's nominal heat requirement, to be able to serve a grid-responsive operation and to help the electricity market with covering residual load. So within a range from 250 kilowatt up to 1 megawatt thermal demand, nominal heat requirement of a building, it's a good idea to pick a unit from this system solution with the respective heating and electric power given in this chart, and looking to bigger buildings or bigger heating networks. It's not possible to build a scalable system solution at all. You have to look for an individual design then. But for the smaller ones, this is a clever idea to combine a standard CHP unit with a standard air-to-water heat pump. We've got 2 delivery charts of heat pumps in the scope. One is coming with a conventional refrigerant for flow temperatures up to 55 degrees. Just an example here with a 80 kilowatt heating power with a COP of a bit more than 2.5. And the alternative is a heat pump series with organic refrigerant, with propane as a refrigerant. At the same heating power, the COP is slightly higher, close to 3. And the flow temperatures, the possible flow temperatures also are higher, up to 70 degrees. So this is what can be chosen from. And with this system solution, the heat demand of a building can be provided like this, like you see it in this sample curve. It's just an example for 250 kilowatt heat requirement. So the smallest possible solution from our side. And if you take a look to the shares of heat which can be provided to a building or heating network, it's about 45% then coming from the heat pump, with about 100 kilowatt heating power at 7 degrees ambient temperature. As you see in the yellow curve, in the summertime, the heat pump is a bit too big, but this helps in the wintertime to cover more of the peak load demand with a heat pump, because it will be big enough to cover a huge share of peak load also in winter times. Of course, you are free to design the heat pump a little smaller than shown in this picture. The scaling of the heat pump in this example comes also from German policy guidelines, Stefan also mentioned the GEG, the building law for heating buildings, and it states that the heat pump has to be big like this for a hybrid system consisting of heat pump and gas boiler. But in the rest of Europe, I'm sure that the heat pump can also be designed a little smaller. The share will be quite the same. The other close to half of the share, so a bit more than 45% again, comes from the CHP unit, our smallest unit, 50 kilowatt, then with about 90% heating power in high temperature level, with additional 18 kilowatts from a condensing heat exchanger, which is possible at that quite low temperatures in the return of 40 degrees. And the rest is less than 10% share then, which comes from the peak load boiler. And the time when the heat pump is running alone, that's the time of the year when a high share of renewable energy is available from the electric grid. So it's a perfect match which can be set up here. So by this, once again, we meet the target triangle of energy policy by combining CHP unit, heat pump, and peak load heat generator with an optimized design on the one hand side and an intelligent operation management on the other hand side. And by this, you can cover environmental sustainability, economic efficiency, and security of supply with one solution. The last two slides are showing a best practice project from our side. It is in Paderborn, not far away from where we are located here in Germany. It's a conversion area of a former British Army ground, which consists of two areas. The one is heritage protected area with buildings from 1889 in the northeastern part of this space. And the other area is a new development space, which is to be set up in the remaining fields of this area. To provide the whole area with heat, two separate heating networks are being set up. First one is a network for higher temperature, so flow temperature is 85 degrees, return 55 degrees Celsius, and this network is supplied by Sokratherm GG202, compact CHP unit with 205 kilowatt electric, 323 kilowatt thermal output, together with a peak load gas boiler. On the right side in the picture, you see the CHP unit flying into the heating building. That's one interesting part in this project, that also the building where all the heating equipment comes in is one of the heritage protected buildings. Here, if you see my cursor, it's this small building right in that area. The second network is a low temperature network with a flow temperature of 45 degrees, 36 degree return temperature, which supplies the new development area from two heat pumps. The first one is a brine water heat pump with more than 600 kilowatt thermal output, which utilizes the source heat from a ground collector field, shown in the graphics on the left side. And the other heat source is the condensing heat exchanger of the CHP unit. And this is a very interesting aspect because we serve the condensing heat exchanger with extremely low temperatures, 4 degrees inlet temperature, 8-degree outlet temperature. So another close to 100 kilowatt thermal power are being extracted on part of the CHP unit, so that the exhaust heat of the CHP is completely utilized and factorized, of course, by the COP of the heat pump. A smaller air water heat pump with 176 kilowatt thermal output covers the load during the transition season. So the ground collector field can regenerate in that time and heat up again in the summertime. Regeneration of the ground connector field is always a very important thing. On the one hand side, the regeneration can be done by putting the collector field offline and using only the heat from the exhaust heat exchanger of the CHP, and the other possibility is using the air water heat pump. And so the ground collector field in the winter always is available with the necessary temperatures. Yes, so this was what I've been requested for today. Yeah, and we are open to your questions in the Q&A session then afterwards. So thanks a lot for your attention.
Thank you very much, Joachim, and an excellent presentation from Sokratherm. I appreciated the demonstration how a heat pump and a CHP are a match made in heaven in marriage, with a little help of digital technologies to tie the two technologies together. And the two examples at the end were very interesting, and I'm sure that this is something that will be replicated more and more as we see the technologies continue to develop, hopefully also with the support of the right policies in place.
Yes, for sure. Thanks.
Thank you. And a reminder to everyone that don't be shy. You can type out your questions in the Q&A function of Zoom. So we still have 10 minutes before we move to and this is a perfect segue to our next speaker. So I'm very pleased to invite Max Funke, who is a sales engineer at Kraftwerke B.KWK, and he'll be presenting an example of best practices in Germany with CHP. So the floor is yours, Max.
Yeah, well, thank you, sir, very much. My name is Max. I'm a project engineer at Kraftwerke. I want to show you some best practices on how to use CHP units in residential buildings. Just from the start, a quick overview on who we are and what we do. We are a CHP manufacturer since 1996, and we had about 100 employees and can support the project from the conception up to decommissioning. Our main products are the CHP units called Mephisto, which have electrical power up to 50 kilowatts, so they are very small units. And we have a controlling unit called the Director for managing the operation of CHP units, heat pumps, and whatsoever. Yeah, CHP in residential buildings. What are the benefits? Quite obvious, I think. The energy production is located exactly where it is needed, so we have minimal energy losses and therefore reduced cost of operation. That is the basic benefit of every decentralized CHP power plant. In residential buildings, we have some challenges we are facing, especially in terms of soundproofing, because simply the people in the buildings want to sleep at night, so we need to take care of that. And in general, there are very limited space which is reserved for technical installments, so we have to take a look on that as well. How we are facing the challenges in terms of soundproofing, it's recommended to have a closed housing, as you can see on the right side, and some silencers for exhaust and intake air. It's also recommended to have a kind of some sort of structure-borne noise decoupling, so that the vibrations of the engine do not transmit to the building itself. And in some cases, you might need an acoustic insulation of the mechanical room. In terms of space requirements, it would be a good idea to have a compact design of the engine, as you can see on the right side as well, and to have a dismountable frame. What I mean by that is that everything you see, it's easy to detach, so you can fit these engines through a small door, for example. And if you face these challenges, it's more or less easy to install CHP units everywhere you want in a building, as shown here in the picture. For example, in the basement, on the attic, or just in the middle of the building. And if there's really no space for the installment, you can put this CHP in a container and right next to the house or on top of the roof. In Germany, there are about 50% of the buildings directly connected to the gas networks. So it's quite easy to find a building where you can put a CHP unit in it. And as Mr. Liesner and Mr. Voigt already told, it's quite easy to install a CHP unit next to a boiler. And that was a classic concept in the last decades, I would say. CHP unit running for about 6,000, 7,000, 8,000 hours a year. But at the time, this had changed a little bit. Nowadays in Germany, we are using CHP units in addition to a heat pump, and was already explained. CHP units in the wintertime with a little bit higher than before, electric output and heat output. Heat pumps in summertime in combination with photovoltaics, which makes a great combination, as well on the financial side and on the emission side. Yeah, and we did this some years ago already. I have an example here. It's a residential area in Gifhorn in Germany. There are 7 buildings connected via a local heat network and a local cooling network. So there are 2 different networks, one for heating, one for cooling. And there's a Mephisto G50 CHP unit next to a geothermal heat pump and a gas boiler to supply the energy which is needed and the cooling. This was built in 2018. Runs very well, and because it runs very well, we are building something like it nowadays as well. Here's an example of a building which is under construction at the moment. And there's a Mephisto G50 CHP unit in addition to 3 wastewater heat pumps and a gas boiler as well. And that's the concept for these types. I don't know how to say the benefits of the combination of a CHP unit and a heat pump would be even more good if the heat pumps would be air to water heat pumps. In these cases, most water heat pumps, and just before a geothermal heat pump could run very well the whole year. And so in these cases, the CHP unit is mostly used to operate the heat pumps. But it would be a great concept with air to liquid heat pumps as well, as shown before. And yeah, that's just a quick overview from my side. Thank you very much. I'm looking forward for questions.
Thank you, Max. Thank you for your presentation and sharing the different examples of different concepts, but also tying in different technologies to provide a global solution. So thank you for your presentation. We have now time for a few questions, and I'm very pleased that we won just now. And then I also have a general question, but maybe more specific for Stefan. But let's go to the first question in the Q&A. It says, for industries with high enthalpy thermal demand, heat pumps are not in the radar. How can they afford decarbonization before renewable become available? So combined heat and power will be off every time cost gas plus CO2 exceeds accordingly on limited hours, limited operations. Any reaction to that question? I think you all can see it as well.
Stefan, you want to start? Microphone.
Yeah, just saw that. I was mentioning several times, at the end, it's about the most efficient combination. And so there is not one best solution from the shelf. And of course, when it comes to high temperature heat pumps, why are customers currently buying that? Because maybe his, I don't know, American mother company says you have to be green, whatever it might cost. And on the other hand, there are mid-sized companies that are very, very close to making money anyhow. Of course, all the manufacturers of high temperature heat pumps, they are focusing a lot, huge efforts in making the technology more and more, or making more and more cheaper. So at the end, so the question was, what happens until enough renewables are there? So at the end, it's about having a incremental approach, what technology is being used in a most efficient manner. Hope I got the question right.
Yeah, when I think of industry, I also think of low temperature demand, like in galvanization, metal process, cleaning of metals, or food process industries, where also temperature at a level of 90 to 100 degrees Celsius is needed. There also heat pump application will make sense, but especially for the high temperature applications, cogeneration will remain the best technology. It will remain to be the best available technology throughout the next years, based on biomethane, biogas, hydrogen, or for the transition period also based on natural gas with the best available efficiency.
Yeah, that's a very good point. I mean, many of the examples that you all shared were talking about flexibility and load following and the heat pumps plugging and playing with CHP. But obviously, industry and high temperature needs of industry are a little bit less flexible. But we've seen that energy intensive industries, such as the paper and pulp industry or the chemicals industry, are also looking into how heat pumps can be utilized to benefit from low temperature heat processes in their overall processes. So there's certainly a scope for bringing in other technologies to complement the CHP on site, may it be heat pumps, may it be other technologies that can utilize waste heat in different ways. It really depends on the local circumstances and what is available to you, of course. So a good question. Maybe I can just end with one question, a general question, and Stefan, you mentioned it already, but maybe you can go into a little bit more detail. Everyone is obviously following the situation in Germany in terms of this plan to install new gas-fired power plants or hydrogen-ready power plants by the 2030s, and of course there are talk of a tendering process for these plants and some sort of new capacity mechanism to support that. Could you maybe talk a little bit to that and maybe the timeline and your thoughts on that and the role of CHP?
That's the big secret currently.
Don't have a crystal ball.
Yeah, exactly. Well, maybe going one step back. So last year, there was the German grid agency said, okay, until 2030, in order to make this coal phase out possible as soon as possible, we need 20 or between 17 and 21 gigawatts of gas power plants until 2031. That was last year. This was just a goal. And then there was over 1 year. I remember there's one of the biggest German magazines. We were allowed to write a guest article, which was a very high-ranked article. And we advocated, okay, we need decentral power plants. I even forwarded in the morning. It was 1st of March last year. And then over 1 year, there were lots of discussions and with ministries, and nobody wanted to make any comment on that. And now what's known is that until 2030, there will be a tendering process for 4 times 2.5 gigawatts. So in total, 10 gigawatt. And the big question is, okay, what about the remaining 10 gigawatt? First of all,
sorry, without any focus on efficiency.
Exactly. So, and also the details on this 10 gigawatt are just not known. So there are no details known. What's known is that the big German utilities, namely EnBW, RWE, Uniper, they sat together with Mr. Habeck, Mr. Scholz, and Mr. Lindner, and they made any kind of deal. I was mentioning it's a secret. And everybody is asking, okay, what about the 10 gigawatt, the remaining? And this is what we have currently the hope that everybody knows who was ever involved in building a big power plant. 6 years or 5.5 years, it's nothing. So it won't happen. Physically, it won't happen. So at the very end, so we can discuss about, I believe that and I believe that. But at the very end, it's about physics. And what will happen in 2030? Either we will buy nuclear power from France, or we will still operate the coal power plants. So politicians, they need to make themselves honest. And this is what currently doesn't happen. And at the very end, I think the physics is on our side, and this is what we currently experience in daily business. That the utilities, the Stadtwerke, they say, I don't know what Berlin is doing. I will just start and do my own things and whatever the politicians say. And this is what's currently what I perceive as quite positive, because at the very end, the electricity needs to come from somewhere. And even in last year or 2 years ago, when we really had this crisis, and when there was even a little chance that the politicians decided to say, okay, nuclear power, maybe it's not that bad. Even in that time, there was a decision against nuclear power, so there will be no turn back. And then on the other hand, the coal power plants, of course, if it's 2030, 38, doesn't matter. But at the very end, coal power, it's not accepted anymore by the world society. So it's about molecules. And when it's about molecules, it's about logical thinking and it's about efficiency. And so at the very end, CHP will have its important point there, I think.
Okay. Thank you, Stefan. Well, we're getting a few more questions in here, but we're running out of time and people are dropping out. Maybe just looking at it sequentially, it's a short question from Hans from COGEN Flanders. What do you see the role of liquid biofuels or e-fuels in the context of Germany?
Yes, I can try to answer. It's rather a question from mobility sector, where liquid biofuels have to be used in the transport sector and for ships, and also in the aerocraft sector. We will not be able to start in a renewable future without biofuels or e-fuels. I don't see them in the electricity sector, but it's the same question regarding green hydrogen in the electricity sector, that many sectors want green hydrogen, like industry, like also transport sector, and on the long end also the electricity sector for residual load for that coverage. And the task will be to share the green hydrogen where it's mostly needed. So what the one central discussion in Germany currently is, do we want to use green hydrogen or liquid biofuels also in the heating sector? And from side of our COGEN Association, we answer no, it's not a good idea to use biofuels in the heating sector, but using the waste heat from electricity production in the heating sector is necessary. And that's what closes the circle in between electricity and heat. So no direct heating from biofuels, but indirect heating from electricity production. That's unnecessarily needed.
Thank you, Joachim. Maybe give Max a chance. There's a specific question for you. You mentioned noise being an issue, especially in residential building. And is there a particular regulation in Germany regarding low frequent noise or anti-vibration measures that you have to take into account when installing a CHP?
Me personally, I don't know if there are any regulations about structure-borne noise. Normal was noises, of course, but structure-borne noise, I don't know. It is quite challenging to get rid of them, but there are possibilities to do so, and it's not necessarily a problem in old buildings, but in new buildings as well, or sometimes even more, because in newer buildings, sometimes the walls are even smaller, even thinner.
Okay.
But there are solutions for every building.
Okay, thank you for that, Max. I'm going to pause here and just take an opportunity to thank all of you. So thank you, Max, thank you, Joachim, and thank you, Stefan, for taking the time to share your experiences and your expertise. It's a very interesting market in Germany, and of course there are challenges, but also opportunities. And perhaps when the secret is better known, we will invite you all back and we can talk in more detail. Hopefully sooner than later. But yeah, looking forward to the developments in Germany. So thank you again to all our speakers. And for everyone who's still online, for your information, we will be organizing our next focus webinar looking at Brazil, and that will take place on the 18th of June. So more information will be made available shortly. So please look out for that. It's an interesting market. It's a growing market, obviously very much focused on the sugarcane industry, but there are new developments and advancements. So if you're interested in the Brazilian CHP market, please do join us on the 18th of June in the afternoon. Like I said, more information will be made available on the website and via social media. And if you're a frequent attendee of these webinars, you will also directly get an invitation. And just for your information, in the fall, we are to look at the use of CHP for data centers, very power-hungry industry. So we will planning to organize a webinar focusing on that particular issue, as well as other thematic issues. And of course, do look out for the third World Cogeneration Market Report that we will publish at the end of the year, and we will have a webinar to share those results. In the meantime, thank you all for your attention and your participation, and we look forward to meeting you all online or perhaps in person at an event in the very near future. So thank you again to our speakers, and thank you all. I wish you all a pleasant morning or afternoon or perhaps good night.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.